All right, guys, you need your review sheets out. We're going over those today. So the first thing we're going to look at is, well, problems 1 through 5, the describing the transformation is going to be bonus points on the test. They're only worth 1 bonus point apiece. And to earn the bonus point, you have to get all the transformations correct on each one of those. I will post a video later today that goes through the entire review sheet, including those. So if you want to go back and watch that, you can. We're not going to go over those in class. It will be Wednesday. We're not going to get through it today.
Yes. Why are you saying yes? Okay. You said you're posting that video.
Mm-hmm. I got halfway through it this morning. I just didn't have time to finish. So I'm going to finish it up later and then post it. Now, the first thing we're going to look at is 6 through 10. Now, we need to attach this with the correct form because it's asking for vertex and axis of symmetry. And these here will come in one of two forms, either in standard form or vertex form. And for problem number 6, it is in vertex form. So it matches up to this here. And our vertex is the point H, comma, K. Well, looking at this here, our K value is outside the parentheses. So it's telling us the value of K is 5. The H value comes from inside the parentheses. So it will be 2. Since it's minus 2 inside the parentheses, it comes out as positive 2. So the vertex for number 6 is the point 2, 5. Now our axis of symmetry, in the general form, it is x equals h. And for this one here, it would be x equals 2. Yeah. We're looking at problem number 1. Not too often, but it does happen. Any other questions on number 6? The next one I'm going to look at is question number 8. Now, 8 is in standard form, our ax squared plus bx plus c. A, b, and c's values will be numbers. We will not have a variable attached to the value of a, b, or c. So the vertex is this point. Now in the general form, it's the point negative b over 2a, comma f of negative b over 2a. And the axis of symmetry is x is equal to negative b over 2a. Now the negative b over 2a, the general form is located in your review sheet. It's in the back on the last page. And the first thing we need to find for any of this here is the value of negative b over 2a. Now looking at our problem here, what would the value of b be? 2. And it would be positive because it's plus 2. And the value of a would be 1. Because we're looking at the number in front of x squared. And it would be 1. Now we could simplify this by hand, or we can simplify it in the calculator. Either one works. So we can say negative 2 over 2 times 1 gives us negative 1. So it tells us the value of negative b over 2a is negative 1, which gives us the x value of the vertex. It also gives us the axis of symmetry. Now that just leaves us the y value of the vertex. And to find the y value of the vertex, we're going to plug negative 1 back into our equation. So we have negative 1 squared plus 2 times negative 1 minus 1. No, these are actually on the test. 1 through 5 were bonus. Now this part here, we're plugging it back into the calculator. So negative 1 squared plus 2 times negative 1 minus 1. And we evaluate it for negative 1. We get a y value of negative 2. So the vertex is the point negative 1, negative 2. And the axis of symmetry is x is equal to negative 1. Questions on any of these here so far? Any other questions on 6 through 10? Which one? Number 9. Now, is number 9 in standard form or vertex form?
Standard.
So we're matching it up to our ax squared plus bx plus c. So we need to find the vertex and the axis of symmetry. Now our vertex is still the point negative b over 2a, comma f of negative b over 2a. Axis of symmetry is x is equal to negative b over 2a. Now to calculate the value of negative b over 2a, we'd have negative, well the value of b is what? Negative 8. A is, so we'd have negative 8 over 2 times negative 2. And we could plug this into the calculator. Negative 8 over 2 times negative 2 is, incidentally, negative 2. So that tells us the x value of the vertex is negative 2. And it does gives us the axis of symmetry as x equals negative 2. Now the last part of this here is to find the other value in the vertex. And we're going to replace every x in the function with negative 2. So we'll have negative 2 times negative 2 squared minus 8 times negative 2 plus 1. And we can type it into the calculator, let it do it for us, and it'll tell us that the value is 9. So the vertex is the point negative 2, 9, and the axis of symmetry is x equals negative 2. Yes. Any questions on any of this here? Okay. We'll move on to 11 through 15. 11 through 15, we want to find the focus, directrix, and axis of symmetry. Flies are nasty and disgusting. Okay. Now, with any of these here, we need to match it up to the general form. Now, there's one of two forms that we have for these here. Either y equals 1 over 4p times x minus h squared plus k, or x equals 1 over 4p times y minus k squared plus h. So it only comes in one of two forms. And for these here, we're wanting to find the values of h, k, and p. So we can use those to find the focus, axis of symmetry, and directrix. Well, what is the value of k for this problem here? 0. We don't have anything added to the end, so the value of k is 0. What's the value of h? 0. Since we don't have a set of parentheses, the value of h is also 0. Now to find the value of p, well, p is equal to 1 over 4 times whatever's in front of our term being squared. Yes. So in the calculator, we can say 1 over 4 times negative 1 over 12, which is negative 3. So the value of P in our case is negative 3. Now it didn't ask for the vertex, but the vertex for this here would be the point 0, 0. Because H and K are 0, vertex is H comma K, so it would be 0, 0. Now the focus for this comes in one of two forms, either H plus P comma K or H comma K plus P. And again, it's going to be determined based off of which equation we're using. And for this here, it's H comma K plus P. And again, I would be referring back to that reference sheet on all of these here. Now we know what the value of H is, 0. But we do need to calculate what K plus P is. Well, that's going to be 0 plus negative 3, which incidentally is negative 3. So the focus is the point 0, negative 3. Questions on this so far? Now the next thing we're looking for is the directrix. Yes, because the general form is y equals k minus p. Well, our value of k is 0. Minus negative 3 is indeed 3. And lastly, our axis of symmetry. Well, the general form is x is equal to h. And our h value in this case is 0. So we get this here. Questions on number 11. You ready to look at problem number 12? Now this one here has x equals. So we're going to use the x equals equation. X equals 1 over 4p times y minus k squared plus h. So looking at this problem here, what's the value of k? What's the value of h? So we have those there. Because there's nothing added to it, so h is 0. We don't have anything inside the parentheses being added or subtracted from y, so k is 0. And our p value is equal to 1 over 4 times the number in front of our term being squared. So we had 1 over 4 times 1/24. Which is 6. It didn't ask for it, but what would the vertex be? 0, 0. So the last one we use h comma k plus p. Would we use that for this one here? Because what's the general form for this one here? Comma k. So our k value this time is 0. H plus p would be 0 plus 6, which would be 6. So 6 comma 0. Directrix. Right? X equals h minus p, which would be 0 minus 6, which is negative 6. And lastly, axis of symmetry. Y equals k. In this case, it is 0. Questions on these here? Any other questions on problems 11 through 15? Okay. We'll move on to the next type. If we do have time tomorrow, we can come back to it, or you can watch the other video. All the ones of this type where we're finding the equation, I will give you the vertex for this here. It's not too overly challenging to find it given the focus and directrix, but we're not going to do that on this here. And again, we need to find the value of h, k, and p. Now the vertex is the point h comma k. So the h value is, and the k value is also 0. Now we need to find the value of p. And we do need to figure out which of the two equations we're going to use. Now, if you're given the directrix, that's one of the easier ones to determine which one it is, because one of the two equations, the directrix is y equals k minus p. The other equation is x equals h minus p. We just figure out which one has a directrix of y equals our k minus p, and the one that does have that is our y equals 1 over 4p times x minus h squared plus k. We just match it up to the general form. But it's also telling us that when I plug the values of k and p into this equation and subtract them, we get a value of what? 2. Now the k value in this case is 0. So we're saying 0 minus p is 2. Or really we're saying that negative p is equal to 2. Now we do need to solve for the value of p, so we can multiply by -1 or divide by -1, which will tell us that p is -2. Questions on how we found the value of p? Now at this point here, we can plug it back into the equation and get y equals 1 over 4 times -2, our value of p, times x minus 0 squared plus 0. Yes, sir. Because the focus for this here is h comma k plus p. And if we were given the focus and the vertex, we could do that because we noticed that the value, the first value is still the same, so it's still h. The other value, k for our vertex, is now changed from 0 to -2. We've added a value to it, so we'd have this here. And exactly, we could have said k plus p equals -2. 0 plus p is -2, or p is -2. Right.
If I could know that, it would be
right. It would be a little bit quicker. Yeah.
We can always just say the focus and that's just
If the vertex is indeed 0, 0. Yes. Now we do need to finish simplifying. Our 1 over 4 times -2. We can do that in a calculator, which gives us -1/8. Our x minus 0 squared, we can just simplify 2 x squared plus 0 doesn't add anything, so we get this here. Well, there was one flying around my empty coffee cup. I had to cover it up because I don't.
so we can just if the vertex is 0, 0. It always is on these. And then we can just do the 1 over 4.
Because if the focus, so if the vertex is 0, 0, h and k are always 0. So in this form, h is just 0. Well, 0 plus p is p, so the focus technically is the point 0, p. Same thing's true with the directrix, y equals k minus p. Well, if k is 0, I just get y equals negative p. So that is the general form of these, and that does work. I do it this way because this works even if the focus or the vertex is not 0, 0. So it works in both cases, yes. Any other questions on this here? So this one's similar, but we'll move on to this one here. Now again, just like with the previous one, we need to find the value of h, k, and p. Now the vertex is the point h comma k, and for us, h and k are both 0. So 0.
Are we giving directrix 2? Or just
No, normally we'll be given 2. We'll either be given the vertex and focus or vertex and directrix. There's only one of the ones on the test that will give you all 3, but most of the rest, all the rest of them will only give you vertex and focus or vertex and directrix. Now, when we look at this here, we're wanting to see how does it change from vertex to focus. Which value changed, our h or our k? H, we added something to it, yes? So this is going to be our h plus p, comma, k. We're seeing which one changed. Since the first one changed, we added something to our h value to get it to change from 0 to negative 10. So it would be our h plus p. And we can refer back to the general form for this here. And this matches up with our x equals 1 over 4p times y minus k squared plus h. Now before we can plug anything in, because I mean, we could, but we don't know what the value of p is, because we need that to really finish this up. But from the general form, if we looked at it as h plus p, if we plugged h and p in, we should get a value of negative 10. But as pointed out earlier, well, for all these here, h is indeed 0, so it's just saying p is negative 10. And that does work. That's also why in the section, I think, 2.31, where it gave us that 0 comma p value, or negative p for the directrix. But the last thing we need to do is simplify. Now, if we plugged in 1 over 4 times negative 10 into the calculator, it would tell us that it's negative 1/40th. And our y minus 0 squared is just y squared. We don't have to write in a plus 0, and we got this here. We do because y minus 0 squared is the same as y squared, and y times itself is y squared. So if we had another number, so y minus 1 squared, we would leave the parentheses. We're not going to multiply that out. Any other questions on this here? Do we need to see another example of 16 through 19? Find the vertex, focus, axis of symmetry, and directrix. And to find that, we need to find the values of h, k, and p. So again, I'm going to match it up to the general form. Since we start off with y equals, its general form will be y equals 1 over 4p times x minus h squared plus k. And if we're looking at this here, what's the value of h? 3. Since it's minus 3 inside the parentheses, it will come out as positive 3. Our k value would be positive or negative? Positive, because it's plus 2 outside the parentheses, it will stay positive 2. And really the only reason we changed the 3 from inside the parentheses, because in the general form it's x minus h, yes? The x's already match up. The minuses already match up. So h has to be just 3. If it had been plus 3 instead of minus 3, it would have come out as negative 3. Now the value p. P is equal to 1 over 4 times the number in front of our term being squared, which in our case is 1 over 8. Again, we can plug this into the calculator. And we get a value of 2. Questions on how we found the values of h, k, and p? Vertex in the general form is the point h comma k. Well, what's our h value? K value is 2. So we get the point 3 comma 2. Our focus, our general form for the focus, if we looked at the equation given us, is h comma k plus p. Well, our h value is still 3. But k plus p we need to calculate. It would be our 2 plus 2, which is 4. Directrix is y equals k minus p, which is 2 minus 2, which is 0. And lastly, axis of symmetry, x is equal to h, and our h value is 2. Yes. Any other questions on the vertex, focus, directrix, or axis of symmetry? Let's look at the next one. So this one starts off at x equals. So we're matching up to our x equals 1 over 4p times y minus k squared plus h. I think it's mostly due to the fact I know what I'm going to write already. And I've already written this problem out 3 times already today. And I will do it once more after this. Yeah. Now what's the value of h? K. Negative 5. Yeah. Value p.
1 over 4.
Which would indeed be 1 over 16. Vertex in the general form is the point h comma k. Our h value is, k value is. Focus for this here would be the point h plus p comma k. Well, our k value stays the same. It is negative 5, but we do need to calculate h plus p because our h is negative 1. P value is 1/16. Negative 1 plus 1/16 is negative 15/16. Questions on how we got the focus? Our directrix is x equals h minus p, which in our case would be negative 1 minus 1/16. And again, we can plug this into the calculator. Gives us negative 17/16. And the last one, axis of symmetry, y equals k, and our k value is negative 5. X equals h, y equals k. So that's another good reason to look back at the general form for all of these here to make sure we get them straight. Now, yes. Now, these points here on the test are worth 9 points apiece. So the vertex, you get 1 point for the negative 1, and you get 1 point for the negative 5. For the focus, same thing, negative 15/16 a point, negative 5 is 1 point. The directrix, you do get 2 points, one for the y equal, or x equals in this case, and 1 point for its value. The axis of symmetry, you get 1 point for the y equals, and then 1 point for the negative 5. And then if you worked it and did do it, you would get 1 point. So, I mean, at minimum, by just looking at the equation, setting up directrix and axis of symmetry, you should get at least 3 points to start with. Questions on this here? Yes. You're good. You all know why parabolas are good at paying attention?
Go ahead.
Because they have a focus. Told a joke to Miss Seitz. I asked her why English teachers are so good at fixing things. Because of their prefixes and suffixes. Any questions on any of these here so far? We're going to do one more, and then we will finish this tomorrow. X equals 1 over 4p times y minus k squared plus h. And I line this up here so that we have the general form, so we can connect and see where h, k, and p line up. I do this so that we can keep the values straight, because in the two forms, one of them, h is on the inside, k is on the outside. And this one here, k is on the inside and h is on the outside. And looking at this here, what is the value of h? 2. And it would be indeed be positive. The value of k would be negative 4. Now we still need to calculate the value of p. 1 over 4 times the term being squared. Negative 3. Incidentally would be negative 1/12. Now, vertex for this here is the point h comma k. So for this here, it would be focus. General form would be what? H plus p comma k. So we do have the k value already. It's just negative 4. But we do need to calculate h plus p, which in our case would be 2 plus negative 1/12. Which if we calculate this here, plug it in the calculator, I believe we should get negative, or not negative, 23/12. Now the directrix, x equals, and in the general form it'd be h minus p, which in our case would be 2 minus 1/12, which would be, or should be 25/12. 25/12. And lastly, the axis of symmetry is y equals k. In our case, it is negative 4. Questions on any of this here?